Hi, pre-calculus students. Today we're going to talk about continuity and piecewise functions. So this is from section 123 in our books. So a piecewise function kind of looks like this. It's got two different rules and for different domains. So here we're going to follow the rule x squared plus 2 when x is less than or equal to 1. And we're going to follow the rule 2x plus 7 when x is greater than 1. So you'll notice that two tables were already set up for us. So for when x is bigger than or equal to 1, we're going to use that top rule. And notice they set up the table so that they put the 1 at the bottom and then everything else is less than or equal to 1. And then we have a table over here for when x is greater than 1. And so we're just going to start by substitute -5 in for x and see what we get. Substitute in -4 for x and see what we get. So we're just going to go ahead and first take a minute to just plot those points. So go ahead, you might want to pause the video and for yourself, go ahead and see what you get for your table. I'm going to just fill these in. So this just comes from substituting the values into the rule. And then same thing over here. Okay, and so then we're going to plot our points. And when we plot our points, we want to plot them. So on this side, we're only plotting for x is less than or equal to 1. And then here you might be saying, wait, this says x is bigger than 1. Why are you including the 1 in your table? Because technically that shouldn't be included. And you're right about that. It shouldn't be. But the thing is, we do want to include everything up to the 1, but not including the 1. So we want to include like 1.1, 1.2, 1.3, even closer one, 1.01, 1.001. So that's why we're going to include the 1, and we'll have a special way of indicating on the graph that it doesn't include that point. All right, so I realize that some of these numbers get up there pretty far. I don't have to plot every single one of them. I just want to get kind of the big idea, the general shape of the graph. All right, I'm actually going to start plotting at 1, 3. And because it does include, it is like when x is less than or equal to 1, I am going to I want that point plotted. So 1, 3, so it'll be about here. And then I have 0, 2, and I have -1, 3, and then I have -2, 6. So here, now this is a parabola. And because I only want to graph it for x less than or equal to 1, I'm only going to graph it like coming down here, and then I'm going to stop right here at 1. But this kind of continues going backwards. All right, now for this other part of the graph, I start with 1, 9, 3, 4, 5, 6, 7, 8, 9, and 1. But I'm going to kind of put a dot there to start. And then it's 2, 11. So then it's going up. It's got a slope of 2, and that's the shape of a line. So I'm just going to kind of go up a slope of 2. And then I will draw the line, but I have to stop at the 1. And because I don't want to include the 1, I really don't want to include the 0.19, but I want to include everything between the 1 and the 2. How I'm going to indicate that is with an open circle. And then I'm going to have this line. Drawing on this isn't the greatest, so I apologize in advance for my lousy line. So I'm going to have that line kind of going up from there. So it ends up with like a piece of a parabola and a piece of a line. So that's why it's called piecewise, because it has two pieces to it. And again, the way that if it's got like a less than or equal to or a greater than or equal to, I'm going to have a closed circle on that kind of boundary point. And here, because it's greater than 1, not including it, I'm still going to start my table at 1, but I'm going to just have an open circle at 1. That's going to be the distinction. So I have two pieces to my graph. That's part of why it's called piecewise. I have one rule for each little different section of the domain. All right, so when we look at 93, it's really the same idea. I mean, this rule is the same rule as in the last one, but it's starting at 2. It's everything less than 2. But I do have a different rule for right here. And so I'm going to start out the same way for when x is less than or equal to 2. I'm going to make a table, right? I'll have my x's, and then over here, I'll have the x squared plus 2. And then I'm going to have another table for when x is less than, greater than 2. And then I'm going to have another table, and I'm going to use this rule here. And when I make my table, I want values that are less than or equal to 2. And when I make my table, I will usually just start with this number, but because it says less than or equal to 2, the rest of my numbers are going to be less than the 2. And because it says the equal to, it's going to be a closed circle. Okay, this one, when I make my table, I'm still going to start at 2, but to indicate that I'm not going to actually include the 2, I'm going to put a little note that it has to be an open circle. And then the values in my table have to be bigger than 2. All right, so I'll plug 2 in here. So when I plug 2 in, that's 6, and then I plug 1 in is 3, and I plug 0 is 2, and -1 is 3, and then get the 6 again, right? And I could keep going. And then in this one, I put 2 in, I get 6, and then when I put 3 in, the slope is half, so it's just going to keep, I said 6, but didn't write 6, right? Okay, it's just going to keep going up by half. And then we're going to graph. So it's going to start out looking pretty similar to the last one, except for we started at 2 instead of at 1. This isn't too beautiful. All right, so 2, 6, 1, 2, 3, 4, 5, 6, and 2 here. And then 1, 3, and then 0, 2, and then -1, 3, and then here. So it's that parabola again. It's just that the parabola went a little further this time, and that was a closed circle. And then when I go to graph this next one, it starts at 2, 6 again, but it's an open circle. So it's like this was a closed circle, and then it's like this one is like kind of wrapping right around that closed circle. And then I have a slope of a half. So is it 2, 6? I think I'll go to 4 and then 7, right? So I have that slope of a half. So then it kind of goes like this. So in this case, the two pieces actually connect. The two pieces connect. So, but it's still an example of a piecewise graph. Now, in the first one, the pieces didn't connect. We would say that this graph here is discontinuous. It is not continuous. And then over here, because the pieces match up, we would say that it is continuous. And so there's a math note in section 1, 2, 3 that talks about the intuitive notion of continuity. So we'll talk more about a formal definition of continuity next semester, but our baby definition of continuity is that you can trace the graph without lifting your pencil, then it's continuous. So here we have an example where, you know, it's got two pieces, but they're connected. And here there's that break in the graph. I'd have to lift my pencil to trace it. Then that would make it discontinuous. And then the other thing I just want to show you briefly is that you can enter into Desmos piecewise functions. So what you would do is you would enter them in two parts. So the first part of our last one was going to be at x squared plus 2. But to show that I want, like for the first one, I wanted to graph this when y was, or x was less than or equal to 1. In braces, I would just type x and then hit the less than key. And then if you hit the equal key, it will morph it into less than or equal to. And you see how it only graphs it for that restricted domain. And then if I go to the next line and type in 2x plus 7, but I wanted to graph this for when x was greater than 1, I would put that into braces. And then you look, you get the different breaks. The only thing Desmos doesn't show is the open circle. So when you look at this, you might say that doesn't look like a function, but if you were to jump on the graph and trace it, it would say right there, undefined, that it is undefined. Okay, and then if I tweak this to the second one, so this was a 2, and this was a 2, and then this was 0.5x, and then what was it, plus 5? Is that what it was? Yes. We can see they connect. And if you were tracing, right, it'd say, okay, it's defined. And then when you jump to that next piece and get closer, you say, oh, it's undefined, but it is an open circle. It just doesn't show it very well. All right, so that is graphing piecewise functions in a nutshell. Have a great day.